start in the back.
I'm just wondering if you are aware of any curriculum that's being developed or has been developed around any of this research?
Wow, that's a great question. That's a terrific question. That was a completely unexpected question. I thought, well, I don't know the answer to that. Not.
You guys want
So
to
you're going to do
repeat?
it?
No, I thought
Repeat the
Dr.
question.
Oh, sorry. Okay, so I guess I'll take that since I'm the only academic up here. The question was, are we aware of any curricula that have been developed to take advantage of the oil spill research? Is that correct?
Yes.
At various universities? I'm certain there have been.
Or lower level, like elementary,
Yeah.
high school.
Oh, that's an even better question, because that would be a really great thing to do. And I think that y'all probably would be better at answering that question for the non-university kind of outreach to public schools, right?
Yeah, I'm not sure. So, oh, do you have?
Yeah, the E.O. Wilson Biophilia Center, actually during the spill, they developed a curriculum. They bring in 7th grade students from Bay, Walton, and I believe Okaloosa counties. And
Right.
they did have an oil spill curriculum there, so I can't remember the name of the contact, but it's E.O. Wilson Biophilia Center.
Okay.
So maybe we can share that link.
And for responders, emergency responders, and natural resource managers, NOAA has a training program called Science of Oil Spills. It's a week-long course. And then they have also other specialized courses. There's a SCAT course and some other things where a lot of this stuff we talked about today is definitely discussed at length.
And I will throw out that we also, our outreach team, also one of those outreach publications that we're working on now focuses entirely on oil on our beaches. So it's going to be a nice summary of all of the presentations that were done today, kind of pulling all that information together in a probably 4 to 8 page little publication, outreach publication. So that might be used as well. Yeah.
Do you have data on how the size of the SRBs change as they kind of bounce along the bottom on their way to the shore?
Repeat the question, please.
You go.
See if you want
I'm
to
going to
take
let
that
you
one.
do that one. Do you have data?
So the question was, do we have data on how the size of them changes with time, basically, as they get rolled on the beach? I actually do not have data on that. I'm not sure if, I thought you had more collection data on size.
We have some data, yeah. And that one of the slides I showed, actually 2 of them. One were data from the laboratory using actual Deepwater Horizon SRBs. Okay, that was that curve that shows the change in the rate of size change over time. And then the other data we have are field collected data. It's predominantly from Dr. Clement, who will be one of the speakers later, and his group of graduate students who he has made walk up and down that beach about maybe 100 times. So yes, we do have data. We do have data.
And in the SCAT data, especially as we got to those trace levels of oiling less than 1%, which was mainly these SRBs, SCAT teams would have been recording the average size of SRB and the maximum size. And in notes fields, which is probably harder to get to publicly, but exists in the raw data, there would have been information on size and shape and things too.
I believe the collection data from the Coast Guard had visual estimates of size, although that would have stopped when the
On the
collection
operations,
data
yeah.
stopped, and
That's
that
true, too.
data may not yet be, that may be under the NERDA, it may not be out just yet.
And even, I mentioned the post-response monitoring that Florida DEP was doing. In each of their reports, and they were out almost every day for about a year, they were recording that, just visually estimating it, but also taking photos of their SRBs that they were collecting, and all that stuff is archived. It's on DEP's Deepwater Horizon site, so every report. So you can see the photos in the background there, if you're interested.
LaDon, do you want
Yeah, Joel, and maybe you can help me reconcile something you said about SRBs posing the greatest ecological risk. I guess it was my understanding that, the components left in those SRBs were maybe, this goes back to 4 years ago when I knew nothing and don't know much more about, the composition of oil, but I always thought those were asphalt beams, whatever those are. I'm not sure if heptane, the one that you referenced, is more or less inert, because I'm trying to figure out the connection between ecological risk,
Yeah.
economic impact, and SRBs.
Okay, so that's a very long question. I won't repeat the whole thing.
Well,
I'll say, what was the what is the, can you further elaborate on the ecological risk statement you made with regard to SRBs? Is that right? They being the, in my opinion, posing the greatest ecological risk. That doesn't mean it's a catastrophic ecological risk. I'm just saying of the things that remain, these may be the most long-lasting relics of this spill, okay?
I got you.
And there are many of the compounds that are known carcinogens and known, to have adverse effects in biological organisms are gone, all right? But there are a few recalcitrant, that means they don't want to go away. There are a few bad players that linger, all right? And I think we'll hear some more about that in the afternoon session. So with respect to risk, keep in mind that I'm not a risk assessment person and I'm not a biologist, but I'm just saying that if you were going to put your finger on something that potentially could be a relic risk, these would probably be the likely candidates.
What would be, where else is oil in the environment other than, in the nearshore environment other than these surface oil residue walls? If these four with the highest risk, maybe because they're the only ones left.
Yeah.
This is not my own research, but Gomer, I know, has funded a lot of work that's looking offshore, because as I mentioned, the mechanism of sand mixing in is a nearshore phenomena, but offshore, the composition of oil can change and it can sink. So I believe there's some studies that you could look up at the Gomer site looking at where deeper there might still be residual oil.
You could talk about oil remaining in marsh environments, buried or subsurface oil, for instance, and how its weathering and its degradation would differ from things on the beach. There could be some comparisons done there that could pull in the biology and ecology as well. It'd be nice, like for your stuff, I think, to take the physical measurements that you have and those changes over time and some of the chemistry, and then link that to the ecological side. Mm-hmm. What risk does that present for shorebirds, for fish that use the surf zone, et cetera?
Yeah, and I mean, that's why we do this research, is to provide that information for people who are experts at that.
Take the next step.
And they can take it and run. That's kind of how we move the ball forward as researchers. But we never did repeat that question.
Yeah.
The question is, where else is the oil?
Where else is oil?
And if you remember that one slide that I showed that showed that distribution that came out of a very early government document, those numbers are still reasonably acceptable, but that doesn't mean it's still there. I mean, those are just kind of how you fractionated out the total amount early on. So where it is now, that's an excellent question. And there's plenty of people, like Soupy was saying, that are working on those types of questions.
And just related to wetlands, next week on August 11th, we are having another seminar. It's going to be over in Slidell. I'll send out the information to all of you, but it's actually, well, it might be full, I think. Yeah, so we'll have the recording on our website, but that's going to focus on the impacts to wetlands. So if anybody's interested, we can send out the recording to that and you can watch the presentations. Any other questions? Yeah?
At some point in the degradation process of these remaining residual compounds, does it become impossible to fingerprint them, and would it be easy enough to make a difficulty in differentiating between sediment, or rather asphalts, that are present already from the degraded roadways on Pensacola Beach, the island seashore property, or Perdido Key?
Yeah, can I take that? So the question was, is there a point in time when you can't differentiate between a MC252 oil, tarball, tarmac, and some other thing, right, like asphalt, for example? And I think the answer is emphatically no, and you'll hear about that this afternoon. But if anybody tells you that, make sure they don't try to sell you a bridge at the same time. Yeah, email Dr. Clement, and he'll visit him.
And I think some of it may depend on where you are as well. I mean, Florida with less, oil input to the system over time, versus somewhere like Louisiana or Texas, where there may be spills like not this magnitude, but similar oils.
Well, okay, so your point is
Still, you can probably still differentiate, but it's more difficult.
Yeah, that is an important point, and let me just readdress that to make sure it's clear. At the chemical level of characterization, there's no way you cannot distinguish between these and any other oil. okay? And that's been well established by our work, other work. There are several papers that have been published. So it's very, I mean, there's no way you can't, with the proper resources, okay, say with 100% certainty that this is from MC252. You can do it, and the time is unlikely to ever occur when that won't be the case. But now if you're picking something up in South Florida that looks like a tar ball and you're not willing to invest the resources to figure that out, then you could be confused by it. Yeah, a lot of these things can look like other things that you just find. But if you take it to the lab and you do the necessary work, you can definitively identify it.
And Dr. Clement is going to be talking about fingerprinting this afternoon. It's the first presentation after lunch. So will you be covering some of that?
A lot.
Okay, so let's, so if we can maybe
Drink some coffee.
we'll have a question and answer period after our afternoon speakers too. So let's hold, we'll talk about that. I'll make a note. We can bring that up again this afternoon. Other questions? Yeah.
What effect will beach renourishment have on the SRBs, sands being pulled from near shore?
So I can take that one. So, obviously nourishment, you're adding sand to the system, so you can be burying things deeper. There's also, I know there's concerns to make sure that where you pull the sand from, the sand mining source doesn't have oil, in it, doesn't have buried oil. So, certainly adding sand to the system will, in the short term, bury them deeper. Usually an area that you're going to be doing beach nourishment is an erosional area. So unfortunately that sand's going away anyway, so it may lengthen the time scale at which things will be uncovered. But, it's, I guess usually you don't nourish in an area where nourishment is expected to leave eventually. So.
There were even some cases in Louisiana where they were doing large-scale restoration projects where oil was buried. There was attempts to avoid that, but some projects couldn't be put on hold long enough, and so you get that burial. And then, again, you can get re-exposure with time, but it extends that time out further. And to talk about other spills, the Tampa Bay spill, they were doing some dredging in, I think, one of the inlets years later, and encountered some oil that was thought to have been from that same spill, and there was a risk assessment done to determine, what they should do in that case. So those types of scenarios can happen.
Do you have something to add to that?
Well, I was just gonna have you kind of re-clarify, for like the sand sources for beach nourishment, on kind of the difference in risk between, say, a very shallow borrow site or a very nearshore borrow site and, say, an offshore site, say 80 foot of water, on the relative risk between the two pumping oil onto the beach.
I can't,
For opportunity for that to happen.
it's, I think that no matter which site you look at, you just have to look to see what's there. Because from the work that we did as far as where these, sand and oil agglomerates could have formed, it's limited. But again, when you get deeper, the oil can be in a different form, and it could have gotten there in a different way. So, because as oil changes in composition, it can actually sink on its own. That's where, that can happen. So, I'm hesitant to make a statement as far as, which is safer, because I think, in either case, the folks that do that have to, look to see where they're pulling it from, so.
Can I address that as well? Okay, so I actually was involved in a project. I don't know if that was did you pitch that one to me, that question? Okay, because it sounds like you did.
No, I
okay.
had the same engineer as Alabama.
Okay,
On the Alabama
yeah,
side.
okay, so the question, for if you didn't hear it, was about beach renourishment and the effects of locating borrow sites, right? And borrow site is where you go to get the sand, basically. And so these are permitted locations, right? And you can't just go out there with a dredge and pump a bunch of sand up on the beach. There's a lot that goes into getting to the point where you can actually take that sand from a site and put it onto a beach, okay? And so Alabama did a renourishment in 2012, I think, yeah. Was that right? I think so. Yeah, we did, go ahead. Yeah, our research team from Auburn went out and we did surveys of the 4 borrow sites, actually 5 borrow sites. I think they only used 4. Looking specifically for oil. And we did towed video where we pulled the video and did very detailed surveys of these borrow sites. We did coring of the sites. We did grab samples, just taking samples off the surface. We did vibrocore sampling. We didn't find any oil at all in these borrow sites. And they were from roughly a quarter mile offshore to about a mile and a half offshore. So, you know, as Soupy was saying earlier, you know, much of this impact along the shorelines is very, very narrow from a geographic extent. Okay, we're talking beach, first sandbar, maybe second sandbar. Would you kind of agree with that?
Yeah.
Yeah, and then you have these SRBs that could roll around in different places, but the major amount of original impacts was in that sand. So.
I think where you can get the most likely projects in your areas, and we're experiencing now with Little Lagoon, is when you have to dredge into a pass and you're wanting to use that sand for a beneficial use. Either, right now, we're doing Little Lagoon Pass using both a hydraulic dredge, but at the mouth, because the dredge is so small, we're having to use mechanical dredging with long reach excavator. Both of those methods are putting tar that's gone
Trapped.
to almost the
Yeah.
extent that you showed on your
Model.
model for Little Lagoon, at least on, is where the dredge first starts picking up tar, which we're putting back into the Gulf, but the tar balls are coming back shore. But even that, the mechanical dredge is where we're getting the most tar because that sand is being placed right back out to the beach.
Other questions? Yeah, in the back?
Start with an observation. One of the things that was evident to us early on in the oil spill in the first days, at least in the panhandle of Florida, is a couple of things. The tides were flooding at night, so we had an increase in sea level in the evening along that's concurrent with our afternoon and evening southwesterly swell or waves that are put up by the prevailing winds in the late afternoon. And the other was when we went out to the beach early in the morning, we would find oil that was stranded, and it would form these layers in these depressional areas in just the micro topography. And then as the sun would heat these up, you would have that mousse would melt literally and soak down into the sand. So it wasn't just the formation of tar balls and the submerged mats were really formed, the larger, I think, were formed on the uplands. And then we had these changes in the shoreline, and these three-dimensional oil-soaked sands were being moved back and forth, and literally in the scale of hours to days. And I think that's helping us helping confound our model predictions of very broad temporal and spatial assumptions based on what's going to be the predominant wave flow and sea level. And I guess if there's one lesson learned, and hopefully there is, would be that we would perhaps look at the three-dimensional changes along the beaches in the micro scale if we ever have an event like this. Because I think that it's those changes in those micro scales, very, very short periods of time, very, very small, I mean, in the scale of maybe tens of meters, where these submerged tar mats are forming and being transported offshore simply by means of where is the shoreline at that particular time.
Okay.
And that's, sir, we had looked a bit about the point that the tide, or if you have a storm surge or a smaller event that will push the water up higher, areas that are dry beach could have had these formed because the water doesn't stay in the same place, obviously. And so that, yes, that's the onshore extent of where these things can be is not always obvious. You have to look to see the shoreline can accrete in the road. So if the shoreline accretes, you can get, that area which is now dry beach or back beach can be an area where these things formed. So that's certainly true. In this case, prior to Deepwater Horizon, NOAA flew stereo orthoimagery, which they were able to get estimates of topography and out into some of the shallow water, and they flew a few flights after that. We didn't have a very recent LiDAR, which would be laser-based but more accurate. Some issue may be that the scale, like you're saying, the microtopography is not something that sandbars and things like that can be captured by things like LiDAR, but, ripples and smaller features that, can bury things enough to make it hard to find is, over the scale, is hard to get. But that's certainly true, that the onshore extent of where these things formed, the water doesn't stay in the same place. So it can be higher than you think it would be because the water may have been there previously.
We found, especially in Louisiana, that we had residual oil not only in the lower intertidal and shallow nearshore areas, subtidal areas, but also in like supertidal washover fans. And that oil would get buried as well, if not by accreting sand from storms, by windblown sand. And those areas over time would break up as well and create SRB fields.
So overwash fans, if you get a big storm, if you have a dune or a berm that's raised up, then the water gets high enough and attacks it, it can cut through and form a breach, and it can cut all the way down, and so you have water flowing through, and it deposits an overwash fan, this fan of sand in the back. So anything that it picks up will be moved with that.
Yeah, in some cases, oil may have stranded as part of those as well,
Right.
or oil that was already on the beach or in the near shore would end up there. So that was another place to look. We also found, Robert, similar to your question, one thing that helped some SCAT at certain times would run beach profiles, repeated beach profiles, looking at buried oil along those profiles and get a sense of how that was changing with time, both the topography and also the movement of oil. That was helpful.
Other questions? Joe?
Yeah, regarding the SCAT assessment, you mentioned that there were a lot of different agencies involved in that. How consistent would you say the efforts were across states?
And can you repeat the question?
Yes, I was just gonna.
Sure. So I think the question was about the SCAT teams and their composition across states.
Consistency,
Yeah.
level of effort.
Was the approach basically the same in all states, or were there any major differences from one state to another?
Similar methods. The teams were different composition, especially the state members. We tried to do calibration, at least a lot of calibration. There was some division in effort between Louisiana versus the other more eastern states. So there may have been some slight differences there, but the overall method was the same. And the team composition stayed relatively stable. At least there were team leads and federal reps that would be there for weeks and months and sometimes years on end. Depending on the state you're in, there may have been more rotation of state members. But I think a lot of folks, because of the duration of the event, a lot of folks got trained in SCAT methods who hadn't been trained before. So I think probably the consistency of the surveys improved over time. And I guess one nuance that many people may not realize is early on, a lot of the SCAT surveys were more rapid. There may have been fewer teams. They were covering bigger areas. They weren't as well trained and calibrated. And they were looking for gross bulk oiling that the response or operations could respond to. Where do we need to get to quickly to get to oil before it gets buried, especially? So those surveys would cover bigger area, go faster, not be as detailed, identifying gross bulk oiling for quick removal. Over time, there were different phases of the response, and this is outlined in one of the papers, where the surveys got more detailed and were capturing more information. So you will see that if you look at the SCAT data through time, the resolution changes a bit. And you have to be aware of that.
Any other questions?
Patricia, about your model, numerical model, I appreciate what you did. And, based on what I saw on those two slides, both at the low energy and high energy, an area called Dixie Bar in Mount Mobile Bay, it looked like that was on the east side of the ship channel, was always a red spot. And I think I understood you to say your validation was based on what was collected. So
Right.
has there been any other work or any intentions of looking at those hot spots based on your model and trying to further validate that?
So as far as so the question was so in the numerical model results, there were hotspots that were identified. And the question was whether there's additional effort focused on validating that beyond what we had done with the Coast Guard data. And as far as I know, the answer is no. The spatial scale, I think, is a little prohibited. As far as I know, there isn't anyone that has been funded to go out and on the large spatial scale, like what the Coast Guard was doing with collection, and now that response has ended, they're obviously no longer getting in data. So it'd be a great data set to have, but as far as I know, it's not being generated at the moment.
Well,
So-
I'm still monitoring, but along with everything else I do. Now, since it's not funded anymore, but I continue to do that. Those are still hot spots. I feel
Never
Be glad to give you any of the data.
required to be a hotspot, but that makes sense.
Yeah, that'd certainly be any.
Area around Fort Moore. In general, the further west you go on the Baldwin side, pretty much the more product we're still seeing. It's the same way during operations, so the data that should be.
If that data is available, that's actually, I'd love to get a hold of anything that anybody has as far as data, because we're continuing this as a USGS effort, but we're very
Yeah.
concerned to make sure we're.
Continued to monitor since we went out in 2013.
Well, if you have money, you can use my button.
Definitely. Did you want to add something?
Yeah, Soupy.
That much sense.
This is an extremely geeky question, okay, so only a professor can ask stupid questions like this. Okay, you know, the modeling work is, you guys have a depth average 2D model, right?
Mhm.
Now, fundamentally, this is inherently a 3D problem. I mean, there's no way sand can contact oil and actually settle. It's a 3D problem inherently, right? So when we depth average, we lost this 3D information. So I'm not even sure what is it?
So 2 points. The mixing model, so the question was, so the numerical model we're using is 2D. So we are looking at the spatial variation, but we don't have a depth component to it. And so the question was, for example, the sand and oil mixing. We didn't use that model to look at the mixing. That's a separate model. So the model looking at the mixing of sand in with the oil mousse was 2D, but the other direction. So it looked at depth and the mixing there. It didn't use the 2D results from Delft 3D. So that's, wasn't used for that. As far as the
But even the currents in general.
right in the surf zone,
circulation-
the currents are generally fairly depth uniform. Longshore currents are generally depth uniform. The exception is like rip currents, but we didn't look at like I said, we didn't look at the cross shore transport. So it's fairly common, in fact, it's extremely common to use a 2D depth averaged model in the surf zone because the currents are very depth uniform because of mixing and because of the process of the waves. The longshore currents tend to be depth uniform.
Even in the surf zone.
Yep, like I said, the cross shore piece, undertow and the process of rip currents, not as much, but the longshore current piece that we were looking at.
Okay, let's take one more question. I know Susan had her hand up, and then we'll break for lunch, so.
Okay, I had a quick Scott question, and I'm sure Joey and Daryl can understand where I'm coming from on this, but are you gonna be making changes on when you're looking, when they're digging down to see the oiling? Because I've done beach monitoring, so I would send in pictures to our officials about why are they only digging down, 20 centimeters or so, when I've documented 3 to 5 feet of sand moving over time. So have you been able to make changes with that? Because I felt like they weren't able to find what they should have been able to find.
Yeah, one thing we preach, sorry. I may summarize it. So I think the question goes to, are we going to make some changes with SCAT related to searching for and finding buried oil? And that's a very good point. And one thing I'll say in general, and that we really preach to SCAT teams in the training and during an event where we're trying to calibrate the teams, is one, digging enough trenches or test pits, digging frequently enough, and 2, digging deep enough. Those are both limitations that we see kind of time and again with SCAT teams. When there's good suspicion of buried oil, or even not, to document that sufficiently. And what ended up happening just in Louisiana as an example, I think probably enough trenches weren't dug. We were also being less intensive with cleanup, less mechanical cleanup happened in Louisiana, less subsurface or buried oil removal. What we got into a situation later on after Florida and Alabama, Mississippi had already removed a lot of that material, is coming up with an augering program where you could get a lot more, basically a small auger mounted on an ATV, where you get a lot more holes punched more quickly in a set pattern, and also being able to dig them, deep enough, quickly enough to better characterize that. So it is a limitation, and I hate to say it, but I always have to constantly drilling that into the teams, even during an event, during the training. You got to have a shovel, you got to dig enough, you got to understand where to dig, looking at the geomorphology, so you're not just digging blindly, but dig blindly some too, and you'll learn more as you go, and digging those trenches deep enough. So if you're an official or an agency that's involved in SCAT or getting input from SCAT, I think feel free to ask that question and drill that in. Are you guys digging enough holes? Are you digging deep enough? Are you digging in the right places? Do we need to come up with another approach so we can document this better?
Okay, awesome. Well, let's have another round of applause for our speakers.